Good morning, students. So welcome back. So today we are going to begin with the new topic, 11th topic, mensuration. In the last topic, that is 10th topic, solid objects, visualizing the solid objects, right? There we have tried to see or visualize the 3D objects, front view, side view and top view, how they look. We have tried to draw them. Then we have tried to find out, or we have tried to actually map the space around us, and that can be utilized in our day-to-day life. Mapping the region around your house, you can do that, okay? It's not so difficult. Then we have seen the edges, faces and vertices of solid objects, and we have tried to classify these solid objects as polyhedron, non-polyhedron, convex polygons, polyhedrons, concave polyhedrons, right? Then regular polyhedrons, and then we have seen what are prisms and pyramids, and then we have tried to find out the relationship between the faces, number of faces, number of vertices and number of edges. Yeah, exactly, Euler's formula. I hope you have understood it very well. And now, continuing further, we are going to begin with the mensuration. Now, last year we have studied, or in the previous standards to be exact, rather to be exact, you have studied about the plane figures to find out the perimeter of them. What is perimeter? Yes, the length of the boundary around the plane figures, or sum of all sides, to be precise and simple. Sum of all sides is nothing but perimeter. Okay, then we have tried to find out the area of these plane figures. Which were the plane figures? Yes, triangle, rectangle, square, circle, etc. Now we are going to study to find out the area and perimeter of different quadrilaterals, like for example trapezium, or we are going to study how to find the area of polygons. Okay, so that's what we are going to study, and in addition to that we are going to find out the surface area and volume of solid objects like cuboid, cube, okay, cone. That's what we are going to study in this particular topic, mensuration. And keep this in mind, this is the base. It is further continued in 9th and 10th. So if I understood this very well, you will find it easy in 9th and 10th. Now, last year we have also determined, or we have also found out the areas of the rectangular paths crossing each other in a rectangular place or field or park, whatever it is. So let us recall one of the example of it. Okay, so there is a figure. I will draw that figure on the board, and questions I will just read it out, and then accordingly we will solve it, so that you will come to know. Okay, now see, this is the figure of rectangular path, rectangular park, and its length is 30 meter and breadth is 20 meter. So the first question, what is the total length of the fence surrounding it? Okay, what is the question? First question is, what is the total length of the fence surrounding it? This is the first question. So we need to find it out. Now fencing, that is to build a compound wall, okay, or wire fencing, okay, wire compound. So suppose if I start from here, so I will be coming here doing the fencing along the borders, So what it is? Yes, it is perimeter. Okay, so therefore length of the fence length of the fence surrounding park is equivalent to, now this is rectangular, so to perimeter of rectangle, perimeter of rectangular park. What is the shape? Rectangular. Now do I know the formula for perimeter of rectangle? Yes, I know. 2 into bracket L plus B. So what is the length? 30. What is the breadth? 20. Now 30 plus 20, yes, 50. And 52s are 100 meters. Therefore the length of the fence surrounding the park is 100 meters. This is just a revision. Last year you have studied the length of the fence surrounding the park is 100 meters. Okay. Now let's move to the second question of this particular figure. Now second question is, how much land is occupied by the park? Now to find out how much land occupied by the park, what we need to find out? Yes, area. What is area? Region covered by the solid figure, that is area. Okay, so how much land is occupied by the park? So that is the question. So I am not writing the question. So therefore land occupied by park that is equivalent to area of rectangular park. Okay, now this is rectangular. Now you know area of rectangle, what it is? Yes, length into breadth. What is the length? 30. What is the breadth? 20. Okay, now 3 to the 6 and 2 zeros, and you need meter square. So meter into meter. Law of indices, a raised to m into a raised to n is equal to a raised to m plus n. So m raised to 1 into m raised to 1 is equal to m raised to 1 plus 1, that is m raised to 2, and hence in area the unit is always square units. Why it is square units? That is the reason. Okay, and hence you have got here 600 meters square. So therefore land occupied by the park is 600 meters square. Okay. Now third question related to this particular figure. Just see how different types of questions have been asked. Now see the third question. There is a path of 1 meter width running inside along the perimeter of the park that has to be cemented. So this is the path. The width of it is 1 meter and it is running along the perimeter inside the park. Okay, so along the boundary inside the park. Now what is the question? It has to be cemented, means we have to put cement on it. Okay, that is concrete. Then what they ask, if 1 bag of cement is required to cement 4 meter square area, so how many bags of cement would be required to construct the cemented path? So what we are supposed to do? Find out the area of the cemented path. So how to find it out? Now I know the total area of the park. I will find out area of the park which is not cemented. Okay, and then what will happen? Subtract this area from this total area. So you will get area of the cemented path. Okay, and then I know for 1 bag 4 meter square. For how many bags? That is the area of the path. Okay, so let us do it. So I know area of the park. So first I will find. Now here, to get the area of this park which is not cemented, I need the length and I need the breadth. Okay, now see, total length of the park is 30, but here 1 meter width road is there, here 1 meter width road is there. So 2 meters subtracted. Okay, one from here and one from here. So 30 minus 1 minus 1. So that is 28 meters, if I am not wrong. Okay, I hope you understand. And same way here. This total is 20, but there is 1 meter path here and 1 meter path here. So breadth, how I can get? 20 minus 1 minus 1, that is 18. So can I get the area of the park which is not cemented? Yes, I can. So first we will write the length, we will write the breadth, then we will find out area of the park which is not cemented, and then we can find out area of the path to be cemented. Okay, so length of park which is not cemented. So that is 20 minus 1 minus 1, that is equal to 30 minus 1 minus 1 is equal to 28 meters. Okay, 30 minus 1 minus 1 is equal to 28 meters. Then breadth of park which is not cemented. So that is equal to 20 minus 1 minus 1, that is 18 meters. Now again it is a rectangle. Okay, so area of park which is not cemented. So that is equal to length into breadth. So what is the length? 28 and breadth 18. Now do I know the tables? I have to. Now 18 8s are how much? 144. Okay, so 14 carry on. 18 2s are 36. 36 plus 14, 50. So 504 meter square. Okay, now I got area of this. I know total area. Can I find area of the path cemented? Yes, I can. So therefore area of path cemented what is that? Area of the park minus area of park not cemented. Now, what was total area of the park? 600. That we have determined. Minus area of the park not cemented, 504. Right? So, how much is left? So 504 plus 6, 510 plus 90. So 96 meter square area of the path is cemented. Now how much? Number of cement bags. So for in one bag 4 meter square area is cemented. Okay, so therefore number of bags required. What you will do? Total area to be cemented. that is of the path, area of the path to be cemented, okay, divided by area cemented in one bag. So area to be cemented is 96 and area cemented in one bag is 4, right? So 4 ones are 4, 4 twos are 8, remainder 1 16, 4 fours are 16. So how many bags are required? 24 bags. Therefore 24 cement bags are required. For what? Are required to cement the path. Okay, so this is third question. Now let us move to the next question. Now see fourth question. There are two rectangular flower beds of size 1.5 meter into 2 meter. So these are two rectangular flower beds whose length is length is 2 meter and breadth is 1.5 meter each. Okay, and rest has grass. So this area is grass. Now the question is, find the area covered by grass. So we know area of the non-cemented park. So the question is, we can find area of these two rectangular flower beds, find one, multiply by 2. Why? Because both of them, they have got same length and same breadth. Okay, so find out area of them too. Then what you do? Yes, obviously, subtract the areas of these two flower beds from this non-cemented park. You will get area of the park having grass. Okay, so let us do that. Okay, so area of one flower bed. That is equal to, it is a rectangle, so L into B. So what is the length? 2 into breadth 1.5. Now 15 twos are 30. So 3.0 meters square. Why 3.0? Decimal point after one digit. So one digit. That too from right hand side towards left hand side. Okay. Now, how many flower beds are there? 2. So area of 2 flower beds. That is equal to 2 into 3. That is 6 meter square. Okay. So you got area of the 2 flower beds. Now, area of the non-cemented park. Area of park which is not cemented. We have determined it. How much it is? 504 meters square. Now what we need to find out? Area covered by grass. So area of park covered by grass, that is equivalent to, what you will do? Area of park not cemented minus area of 2 flower beds. If I know the plan, it becomes easy for me. So we are preparing the plan. Now, do I know area of the park not cemented? Yes, I know. 504. Do I know area of the 2 beds? Yes. How much it is? 6. So 504 minus 6. So how much? Yes, exactly. 498 meter square. So area of park covered by grass is 498 square meters. Okay, so that is what the answer is. Now let us move further. We can find the areas of figures other than rectangles, right? If certain measurements are given, definitely. So let us do the match the following. Okay, so diagram and its shape is, name of the shape is given, and you have to match the area for that. So the first figure is rectangle. It is given here, rectangle. Now what is the area of rectangle? Whose length is B and breadth is A. Yes, exactly. A into B. Where it is? Oh, here. Match it. Okay. Then, next figure is square, whose length is A. Now, square, all sides are equal. So, what is the area? Exactly. Side square means A into A or A square. Let us see where it is. Oh, yes, here it is. So, let us match it. Right. Then, third figure. What it is? Triangle. Right? Now, this is the height, this is the base. We have studied what is the area of the triangle? Half base into height, when base and height is given. Right? So, half, your base is B, height is H. So, half BH, where it is? Here. Okay? So, match it. Right? And parallelogram, whose length is B and height is H. So this length, it acts as the base, right? So area of parallelogram, yes, base into height, that is B into A, H, where B is the base and H is the height, and left is circle, right? What is the radius here? B. So what is the area of circle? Oh yes, pi r square. And where is it? Pi b square. So here it is. Okay? And so thus we have completed the match the following. Now next, try this page number 170. Now see, try this page number 170. First one, A. Match the following figures with their respective areas in the boxes. So I have drawn the figures and I have drawn the area. So we have to match this. So the first figure is, oh yes, it is parallelogram. And what is the area of parallelogram? Yes, base into height. So here area is equivalent to B into H, that is 14 into 7. 14 7 is 98. So 98 square centimeters. Do you get it? So first figure. We'll match here like this. First figure. Okay. Then what figure is this? Semicircle. And area of circle is pi r square. Area of semicircle is half of it. So half pi r square. Now, so area will be equivalent to half into pi r square. So that is half into 22 upon 7. Now here radius is 7. This is also radius. This is diameter 14. But this is radius 7. Okay. So 7 square. So 7 into 7. So 1 7 gets cancelled. And 2 ones are 2. 2 11s are 22. And 11 sevens are, yes, 77 centimeter square. So which one? Yes, second. So here it is number 2 figure. Okay. Now see, area. What figure is this? Oh yes, triangle. So area of triangle. What it is? Half base into height. Now what is the base? 14. What is the height? 7. So 2 ones are 2 sevens are. And 7 sevens are 49. So figure number 3rd. Right? Okay. Then see this figure. What it is? Rectangle. Rectangle, you know what it is? Area. Length into breadth. So L into B. So that is 14 into 7. 14 sevens are? Yes, 98 centimeters square. So figure number 4, you get here 98 square centimeters. And last figure, what it is? Obviously it is square. So area. Area is what? Side square. Am I right? Yes. So side square. Now side is 7. So 7 square. Square of 7? 49. So 49 square centimeter. किधर है? First one. So fifth figure. Do you understand? So question A is completed here. Now question B. Question B is write the perimeter of each shape. Now that question I leave it to you as homework. Okay, so I am writing here homework. This is just a recall. We are studying all this revision. You have studied last year. Okay, so homework, try these. Page 170. Okay, B question. Find the perimeters of the above figure. So that you will do it. And so dear friends, we'll be back in the next period. So after the exam, definitely. Okay, you have got your now weekly tests. And so we'll be meeting after that weekly tests. So at that time we will solve exercise 11.1 and we will move further for the next areas of the figures to be calculated. Okay, so with that consideration, let us stop here. If there are any doubts, definitely you will ask me. So let us meet in the next period. Till then, goodbye. Thank you.